So I want to talk a little bit about why we actually have those requirements of being continuous and being differentiable. So let's just title this, Why Do We Need the Requirements? The continuous requirement. You know what, I'm just going to try to draw a graph, and we'll see if we can kind of justify from the graph why, yeah, the mean value theorem isn't going to hold there. Let me do something that looks like this. Say this is A, and this is B, and I'm going to do something like this. It's going to jump down to something kind of like this. It's my function f of x. And I'm going to go draw in my secant line, the slope through those endpoints. So the slope of the line through that point and this point looks like this. Looks like a slightly negative slope. Do you see anywhere on that function where the slope is a little negative? Not going to work. Could I have drawn something discontinuous with a slope that would occur on the graph? Sure. It's just not guaranteed. This is kind of like the intermediate value theorem in the beginning of the year. Can we guarantee that somewhere the y value is going to be 10? Maybe not necessarily, but could the y value be 10 somewhere? Sure, it could be. We just can't guarantee it. We're trying to guarantee a particular slope happens, can't guarantee it if we're not continuous. Let me give you an example of something that is not differentiable, where this will also fail. Let's take a look at something like this. Between A and B, something here, and then I'm going to do a sharp turn, and then it's going to come up there. After you copy that down, draw in your secant line and kind of convince yourself that, yeah, the slope of a tangent line will never actually equal that thing. You believe that we'll never actually have that slope on our graph? Maybe, possibly. I only really see two slopes, this negative slope, that positive slope. I don't see that positive slope anywhere. Not going to happen. Have to be continuous, have to be differentiable. So, continuing our examples of applying the mean value theorem, let's apply it to the function f of x equals 3x to the 2/3 on the closed interval between -1 and +1. Step number 1. Are we continuous? Really, we should be looking for like denominators. Do we have any denominators here? No, do I have any square roots here? Square roots. What sort of root do I actually have? Cube root. Can you do the cube root of any number? Sure you can. Square roots, no, can't do square roots of negatives. But yeah, this is perfectly good. We are going to say that f of x is continuous on -1, 1. Find your derivative and check the differentiable thing. And once we have that, then we'll go and find the slope, assuming that the mean value theorem holds. 2 over x to the 1/3. Are we differentiable between negative 1 and 1? Yes, we're good? No, we're not. Can someone tell me why one of those answers is correct, Sabrina? And is 0 within our interval? Yeah, it is. If I wanted you to do this problem between like 2 and 8, we'd be perfectly okay. But this thing is discontinuous at x equals 0. The derivative was discontinuous there. So no, we are not differentiable on that open interval between negative 1 and 1, and the mean value theorem doesn't apply. There is no slope that I can guarantee will occur. And I'm going to switch back to the computer.